question 8a, complete the table below. The value of h1 is given to us. So basically all we're doing here is we're subbing our t, our time, into our function h of t. So for instance, with, let's say we do this one here. So we're finding h of 3, which is equal to taking my function 72 minus 60 times cos times pi over 3. So just make sure your calculator is in radians for this question, and I'm subbing in 3 for t. So that's basically what I'm putting into my calculator. And for my first value there, for say h of 3, I'm getting 132. So I've done these out, so I'm getting 12. Actually, what you could have done in your exam here, or if you're doing it as practice, you could have tested t of 1, and you should have got 42. And filling in the rest of them, 102, 132, 102, 42, because it's going around in a circle, so that's why these are repeating each time. 12 when it's at its lowest, 42, and 102. It's then asking us in part B to sketch the function, draw the function h of t between 0 and 8. So my first point there to plot is going to be 0, 12, which is here on the y-axis. My next point then is 142, which is here. And my final point, 8, 102. So there's my points plotted. I now need to create a freehand curve connecting all of those points. Which should look something like that. And I should just rub off ignore this part here and at the end here, because it's between 0 and 8. So looking at part C, find the period and the range. The period is how often the curve repeats, and the range is basically the maximum to the minimum. So we'll start with the range. Actually, it could be a little bit easier. So if I'm looking at the range, first of all, the minimum point or the lowest point of the Ferris wheel is at 12. So we can either take that from my curve here, it's coming across to 12, or if you go back to the original drawing they gave you, you can see here that the lowest height is 12 meters. So that's my minimum on my range. And my maximum, again, you can take these from your table as well, which is 132. So once again, I can use my my sketch to come across to my 132, or you can come back to your table and take it from here that the highest point is 132. So there's numerous ways you can get those values. So that's 132. And the next part is asking us to find the period for the function. So how often does the function repeat? And this function repeats every 6 minutes, because if you go from, say, time 0, it's at 12 meters. When is it at 12 meters again? Well, it's at 12 meters again 6 minutes later. So my period here is 6 minutes. Looking at part D, during a 50-minute period, what is the greatest number of minutes for which the point A could be higher than 42 meters? So there's two ways we could look at this question. We could use patterns and sequences, or we could use our trigonometry. Let's look at, first of all, using patterns and sequences. And after this, I'll do it out using trig, so you can basically take whichever one you prefer. So if we look at our table here again, we'll scroll back up here for a second. So on our table, we're looking for above 42 meters. So here you can see it's at 42 meters at time 1, and then it drops below 42 at time 5, and then it goes above 42 again at time 7. So I'm basically just going to continue that sequence so you can see what it looks like. So if I scroll back down here again, you can actually see it from my graph here as well. There's time 1, it's coming up to 42, and that's from the table really. And then at 5, back to 42, then it drops below 42 until 7. So as I said, I'm just going to continue that sequence here. So if we come back down, I'm just going to list out all those digits really. So we're going to have time 1, then we're going to have up until time 5, then time 7, and then time 11. So let's just see what that basically means. So from 1 to 5, it's 4 seconds. That's above 42. So I'm going to highlight that as one of my quantities that I need. Then if we were to scroll back up to the table, between time 5 and time 7, that's 2, but that's below 42 meters. So I don't actually need that one. So I'm actually going to leave that one out. So I just basically want to continue this sequence. The next 4 minutes here, I do want to include because that's going to be above 42. So I'm just going to highlight that. And look at it, I basically just continue my sequence. So I'm just going to keep going up here. My next one, I'm going up in 2. So that's going to bring that to 13. Then I'm going up in a 4. That's bringing me up to 17. Then in time 2 brings that up to 19. Add a 4 brings me to 23. Add a 2 brings me to 25. Add 4 again, which I'll be above, will bring me to 29. Add another 2 brings that to 31. Again, what I'm trying to do here is just to include 50 minutes. 31, where am I going here? I'm adding another 4, which brings me to 35. Add another 2 brings me to 37. Add a 4, 41. Add a 2, 43. Add a 4, 47. Add a 2, 49, and we'll add another 4 here, and we'll sort that out in a minute. That's going to bring me to 53. Okay, so highlighting the 4s because these are the ones which are above 42 meters. So let's just highlight these ones for a second. So here I have 1, 2, 3, 4, 5, 6, 7, 8 4s highlighted. So I'm just going to go 8 by 4, which is 32 minutes. Next thing I need to do, I need to deal with this little corner going on over here because that's from 49 minutes to 51 minutes. Now, just remember here, I didn't start at time 0. I started at time 1. So here is my time 1. So technically, I have to go, my range here is from 1 to 51 because it wants it in a 50-minute period. But I'm not starting at 0 to 50, I'm starting at minute 1 to 51. So when I come back down to the back end of my table here, let's just see what I have to sort out. I'm at 49, so I basically need to bring this up to what, 51, isn't it? Which means I need to just add on 2 more minutes. I can't add on the extra 4 because it wants it in a 50-minute period. So I just need to add on this extra little section at the end here. So my final answer there would be 32 plus my additional 2 minutes, which would be 34 minutes in total. Let's have a look at this now through trigonometry. So my function given in the question is h of t is equal to 72 minus 60 cos pi over 3 times t. So that's the function I'm given. It's telling us then where it's greater than 42. So I'm just going to let that equal or greater than 42. I'm looking for when it is 42 basically. So I'm just going to use an equal sign here. And I'm going to solve this here. So I'm going to move over my 72, which is minus 60 cos of pi over 3 times t is equal to 42 minus 72, which is minus 60 cos of pi over 3 times t is equal to minus 30. I can divide across by that negative 60 now, so cos of pi over 3t is equal to negative 30 over negative 60. So I have cos of pi over 3 times t is greater than 0.5. So now let's look at our cast, our unit circle now. So we're looking at CAST. So cos is positive, all are positive, sine is positive, tan is positive. And I'm looking now at the angle pi over 3. So it's positive here. That would be my reference angle, and it'd be positive down here where cos, because the function h of t is cos. So they're my two regions that I'm looking at. Now if I come back here and examine our function. So if I solve my function here, I'm going to have pi over 3 times t is greater than cos inverse of 0.5. Now again, just be careful, have your calculator here in radians. So that's giving me pi over 3t is greater than 1 over 3 pi. But we could also have, so let's come over and do it again, or I could have, let's look at this region in here. Now, this region has pi over 3 as our reference angle. How do we get the size of this angle? Well, our full circle is 2 pi, and I'm going to subtract the pi over 3, the reference angle, which is giving me a 5 over 3 pi here. So that's the angle from here to here, basically. That's 5 over 3 pi. So I also have pi over 3 so I have pi over 3 times t is greater than 5 over 3 pi. Now I'm looking for the general solutions here, so I need to add on my plus a rotation, so 2n pi, or 360 basically, and then here plus 2n pi. So I need to do out both of these now, general solutions, by subbing in values for n, 1 rotation, 2 rotations, so on and so on and so on. So let's start. Let's let n is equal to 0, and coming down to my first one here, I'm going to have 1 over 3 pi plus 2 times 0 times pi. Working that out in my calculator now is giving me t is equal to, sorry, that's pi over 3t, I should say. So pi over 3t is equal to 1 over 3 pi. To get t on its own, then I go 1 over 3 pi and basically dividing across by pi over 3, which is giving me a value of t when n is equal to 0 of 1. So t is equal to 1. And I now come over and I'm going to do the same for my other general solution. So let n is equal to 0 here, and I'm going pi over 3t is equal to 5 over 3 pi plus 2 times 0 times pi. So that's going to give me pi over 3 is equal to 5 over 3 pi. And to get t then on its own, divide across by pi over 3. So 5 over 3 pi divided by pi over 3. And that's giving me a value of t of 5. So I just need to basically continue that now. That's n is equal to 0. I just need to continue that until my highest value for t is up to the 50-minute mark, basically. So I just need to keep going with this. So I'm just going to write down some solutions, a few more solutions here. So let n is equal to 1, let n is equal to 1. When I let n is equal to 1, I get t is equal to 7 and t is equal to 11. When I let n is equal to 2, I'm getting t is equal to 13, t is equal to 17. When I let n is equal to 3, I'm getting t is equal to 19, t is equal to 23. Let n is equal to 4, I'm getting t is equal to 25, t is equal to 29. Let n now equal to 5, t is equal to 31, t is equal to 35. Let n is equal to 6, I have t is equal to 37, t is equal to 41. Let n is equal to 7, t is equal to 43, and let n is equal to 7 again, I get t is equal to 47. And I'm going to go one more time. I let n is equal to 8. And I'm getting t is equal to 49. T is equal to 53. Okay, so what does that mean now? You can hopefully see that the gap between each of my times, so the gap here between, say, 19 and 23 is 4 minutes. Here it's 4 minutes, so it's 4 minutes each time. So if I just zoom out a little bit more here, we'll try and visualize that all the way to the 0 here. It might be a little bit small, but the gap that you can hopefully see is now 4 minutes between each. So 4, 4, 4, 4, 4, 4, and 4. So how many 4s is that? 1, 2, 3, 4, 5, 6, 7, 8, 9 4s. Sorry, yes, that's 9 4s, but we need to exclude this one because it goes above the 49 to the 53 because it only goes up to 50-minute period here. So that's 8 4s. So therefore my final solution here would be 8 times 4, which is 32. And on to that, I need to add on 2 additional minutes because these additional minutes are from, we started at t equals 1. So if I'm starting at t is equal to 1, I need to bring that all the way up to t is equal to 51 because remember, this has to be a 50-minute time scale. So I'm not starting from 0 to 50, I'm starting t is equal to 1. So in a 50-minute period, that is going to go from 1 to 51. So that's why I'm adding on the extra 2. So that's giving me 34 minutes in total. Part E. By solving the following equation, find the second time value of t that the point A is at the highest, the height of 110 meters. So we're solving the equation here. So 72 minus 60 times cos pi over 3t is equal to 110. So first thing I'm going to do is move over the 72 or subtract 72 from both sides. So that's giving me minus 60 cos of pi over 3t is equal to 110 minus 72, which is giving me a value of 38. I then divide across by the 60, so cos pi over 3t is equal to 38 divided by negative 60, I should say, which is giving me cos pi over 3t is equal to minus 19 over 30 when it simplifies down. If I do the cos inverse of that, I get pi over 3t is equal to cos inverse of negative 19 over 30, which is giving me pi over 3t is equal to 2.2566. And to get t in its own, I divide across by pi over 3. So 2.2566 divided by pi over 3, which is getting me a value of t of 2.15 minutes. And if you come back up to your picture here, your sketch in part B, look at 2.15 and it's 110 meters. So 110 meters is roughly here, which looks about right. It looks about 2.15 meters. Now we're looking for the second time. So the second time is over here now. So we're looking for this time. And that looks, it's somewhere above 3.5. So we're probably looking for maybe 3.7 or 3.8 minutes. So that's what we need to prove now for the second time in part E. So from my log tables on page 13, I know that 1 radian is equal to 57.296 degrees. That's from page 13 in the logs. Now, that tells us then that if I want 1 degree, it would be 1 radian divided by 57.296 degrees. And aim to get 180 degrees, I multiply this by 180, which is giving me an equivalence of 180 degrees as 3.14 radians. So that's what the value of 180 degrees is in radians. Now, coming back to our question here, we know that using our cast again, so if we look at our CAST here, all positive, sine and tan are positive. Now I'm looking at where cos is negative because it's minus 19/30. So it's negative here. And it's also negative then in tan being positive, so negative in here. So my first answer I got was 2.25 as my answer over here. So this value here. So if I come back now to my radians and find the size of the reference angle in here. So I have the full semicircle, or half of my circle here, to be 3.14 radians. I subtract the angle I already have, which is 2.25, and I get 0.89. So this angle in here, my reference angle, is 0.89. So to get this angle then in here, I need to go my 3.14 plus my reference angle, 0.89, and that's giving me 4.03. So the size then, let me just sketch it out neatly here on a separate coordinate graph. So this angle in here, where tan is positive, this angle from here to here is 4.03 radians. So therefore, I'm now going to come back down. I'm going to take this section here, redo it, but letting it equal to 4.03. So my final step here is going, I'm running out of space here. So I'm going pi over 3t is equal to 4.03. Solving for t, so t is equal to 4.03 divided by pi over 3. T is equal to 3.85 minutes. So that's our second value for t. Part F, use integration to find the average height of the point A over the first 8 minutes that the wheel is turning. Give your answer correct 1 decimal place. So the key here to this question is where it says the average height. So we're basically finding the average value of a function, and the function that we're given is 72 minus 60 cos pi over 3 times t. So in this question we need to integrate our function, and then we're going to find the average value of it. So we're basically going to integrate 72, so that'll become 72t. And when we integrate cos, we get sine, so it's going to be minus 60 times sine pi over 3t. And then we divide by the value in front of our variable, the t, so that's pi over 3. So that's the integral of our function. Now we need to find the average value of that, and the formula for the average value, or the process to carry that out, is the fraction 1 over b minus a. And then we need to find our integral from the limits b to a and our function h of t. So we have our value, so it's to the first 8 minutes. So setting up, it's going to be the average value from 8 to 0, the first 8 minutes. So that's 1 over 8 minus 0. And I have my function h of t. So subbing that into my integral, it's going to be 72 times my t, which is 8, minus 60 times cos pi over 3 times t, which again is 8. And from that, I need to subtract the integral, or the value, when I sub in 0. So subtract 72 times 0 minus 60 times sine of pi over 3 times 0. And I forgot, actually, this is all over pi over 3. Over pi over 3. So I'm subbing in 0 this time for t. And don't forget, I need to multiply all of that by my average value. So to the front of this, so let me just change the color of the brackets here. So all of this needs to be multiplied by 1 over 8 minus 0, which is 1/8. So how's that going to look? So I'm going to have 1/8 times, multiplying all this out now in my calculator, 576 minus 49.62, subtract, well, 72 times 0 is 0, and this will also give me 0. So that's going to be 1/8 of 526.38 subtract 0, which is giving me 1/8 of 526.4 if we round it to our 1 decimal, which is giving me an answer of 65.8 meters. And that's part F complete.